Hi everybody, I hope this video finds you well. In today's video, we're going to be taking a look at the Math150Practice0 worksheet. This is a set of practice problems that sort of focused on the prerequisite skills that you need for our class, with sort of a special emphasis on converting between percentage and decimal and percentage, and also just having a better understanding of percentages, which is something we're going to use a lot in our class. If you haven't already tried these practice problems on your own, I highly recommend pausing this video, trying the problems yourself, and then coming back and watching these solution videos. If you're already done all these questions and you feel very confident about what you sort of did and you just want to check your answers, keep in mind that there is an annotated version of this document with all the sort of work and answers written out in the description of this video, so down below if you're watching it on YouTube. So if you just want to look at the sort of solutions, you can look there. If you want to sort of follow along though and listen as we work through these, well, then this is the video to do it. So let's go ahead and get started by taking a look at question 1 here. So question 1 was simply just doing some conversions. We want to convert some fractions to decimals, percentages to decimals, fractions to percentage, etc., etc. So let's go ahead and we'll give ourselves another page to sort of work on. We'll grab these questions here, and there we go. We'll take that and we'll bring that onto the next page here. So this will be question 1. All right, so there's everything that we want to work on. All right, so the first thing that we have to do is we're trying to convert a fraction into a decimal. This should be very straightforward, especially since in our class you guys are allowed access to a calculator. Remember that a fraction is just notation for a division. So if you want to convert 47 over 56 to a decimal, all you need to do on your calculator is do 47 divided by 56. You should get a long, sort of messy decimal. In our class, the general rule of thumb is to always save 3 decimal places. So we would say 47 over 56 is approximately 0.839. Of course, it's 0.8392, but since that is a 2, remember, the rule for rounding is if the next digit is 0 through 4, you keep this one the same. If the next digit is 5 through 9, you round it up. Would it be incorrect to save more decimal places? No. In this class, you are never going to be marked off for saving more decimal places than necessary. But if you want to keep things pretty simple, 3 decimal places should generally, unless otherwise mentioned, be a good level of accuracy to keep. All right, let's look at B here, converting 85% to a decimal. Remember that the trick for converting from percentage to decimal is to move the decimal place 2 places to the left. So the decimal place here would be sort of implicitly at the end because it's 85%. If we move it 2 places to the left, we should get 0.85. So 85% as a decimal is 0.85. Converting from a fraction to a percentage is a 2-step process. First, we need to go ahead and get it as a decimal. So again, as a decimal, we do the division, 8 divided by 92. We should get that 8 divided by 92 is approximately, if we're keeping 3 decimals, 0.087. If you're on your calculator, you should see 0.0869. Since it's a 9 in the 4th spot, we would round up to 0.087. Then we can say that that is directly equal to 8.7%. How do we get that? Well, remember that back here, when you're converting from percentage to decimal, you move 2 places to the left. When moving from decimal to percentage, you move 2 places to the right. So we go once, twice, and that's how we get that 8.7%. All right, we've got 0.74%, so a very small percentage being converted to a decimal. Remember, to convert from percentage to decimal, you need to move 2 places to the left, so 1, 2. That means we'll have 2 extra zeros added. So as a decimal, this would be 0.0074. It's a very, very small decimal because it's a very, very small percentage. Here's another decimal to percentage, meaning that we need to shift the decimal place 2 places to the right. If we do that, 1, 2, we would get 99.08%. It is totally fine to have a decimal still in the percentage because it's a percentage that is just a pinch higher than 99%, 99.08. Finally, we've got sort of a messy one here, 2 divided by 697 to a percentage. Let's first start by getting the decimal, so 2 divided by 697. We should get that 2 divided by 697 is approximately, looks like if we're keeping 3 decimal places, 0.003, because it's 0.0028, so we would round up. And then as a percentage, we need to shift 2 places to the right, and we should get 0.3%. So there we go. There's some conversions, but pretty much the main conversions you need from this class: fraction to decimal, fraction to percentage, decimal to percentage, percentage to decimal. If you're comfortable with these, and remember, for the actual computations like these divisions, you're not doing them by hand, you're just using your calculator, you should be all good. All right, let's go ahead and take a look at the next question then. So the next question is not just about conversions, it's actually about determining some percentages based on some information. This is really some data-driven stuff. If you guys have gone a little further in the material, depending on where you are, you'll know that this is what we would call a categorical variable, because we're asking people to put themselves in categories. This question in particular was about surveying people about their preference between cats and dogs. So it would be called a Boolean or binomial categorical variable, because people were only given 2 choices. They either had to pick that they prefer cats or that they had to pick that they prefer dogs. So let's grab this information and then work through these pieces on the next page here. So copy that. All right. So this will be question 2 here, and we'll go ahead and paste this in. Okay, I probably need to expand that just a little bit. Okay, perfect. So we'll go ahead and zoom in. Alrighty. So we've got this survey where we had 500 people. There were 300 men and 200 women. Notice that makes up the 500 people. For the men, we have information that 177 preferred dogs and 123 said cats. Notice that 177 plus 123 is 300, so that makes sense. And for women, it was 108 that picked dogs, 92 that picked cats. 108 plus 92 does give us that 200. First question we have is, what percentage of men said that they preferred cats? So for this, all we would need to do is we would need to take the men who said that they preferred cats. We know that that's 123. So we'll take 123 and divide that, because we want the percentage of men out of the total amount of men. So out of 300 there. We can do that on our calculator. 123 divided by 300. We should get that is 0.41 as a decimal, but of course we want it as a percentage. So shifting this thing 2 places to the right, we should get 41%. So we can say that 41% of men in our sample said that they preferred cats. All right, well, let's try B here. For B, we want what percentage of women said they preferred dogs. So for our numerator, we'll find the amount of women that said that they preferred dogs. That was 108. So that'll be our numerator. And that 108 is out of the total amount of women. Why is it out of the total amount? Because we want the percentage of women. So it's telling us out of the total amount of women. There were 200 women, so it's 108 out of 200. We can do that on our calculator. 108 divided by 200. You should get a decimal of 0.54, which then as a percentage is 54%. So we could say that 54% of women in our sample said they preferred dogs. All right, finally, for C, we want what percentage of people said they preferred cats. Now this time it's the percentage of people, which means that our denominator is not going to be 300 or 200. It's going to be the overall sample size, which was 500. So this one is going to be something divided by 500. How are we going to find the numerator? Well, we need to figure out everybody who said that they preferred cats. That means we need to combine the for cats, 123 men that said that, and the 92 women that said that. So we'll have 123 plus 92. So we'll add those things together. We'll go ahead. Remember, order of operations would tell us that we need to handle things in the numerator and denominator separately first. So let's go ahead and add those up. 123 and 92. So that's 215 out of 500. Notice that what that 215 represents is that there are 215 people, regardless of gender, that picked or said that they prefer cats to dogs. Now we can go ahead and do this division. You should get that this is 0.43. So that would be 43%. Alrighty, so there we go. There's some examples of making sure that you can calculate percentages based on some information here. The key thing is that you want to make sure that you read the percentage of what group you're being asked, because it said percentage of men, we use the total amount of men, percentage of women, we use the total amount of women, and the percentage of people, we use the total amount of people. All right, let's go ahead and take a look at some more questions here. So for question 3, we're going to sort of do the opposite. We're going to be looking not at trying to get percentages, but we're going to start with some percentages and try to use those to get some actual amounts here. So let's go ahead and we'll grab this and we'll give ourselves sort of a fresh page to work on there. Okay. There we go. So this will be question 3. We'll go ahead and paste that in. Make it a little larger for us. There we go. So let's go ahead and take a look at this. So in this one, again, we have some data. Again, if you've done a little bit more so far already before looking at this practice, you'll know that this is a categorical variable. We're talking to a group of 260 adults about their beverage drinking habits. So we know that 63.8 say that they drink coffee regularly, 23.1 say that they drink tea regularly, and 50.4 reported that they drink soda regularly. So you'll notice that the first 3 questions all say how many adults in your survey said they drink coffee, drink tea, or drink soda regularly. Notice that now we're given these percentages and we're trying to figure out how many actual adults, like the number of actual people that said that they drink coffee or drink tea or drink soda. So in question 2, you'll see that when we were doing this and we wanted to get percentages, we were doing division, yields us a percentage. If we have a percentage and we want to get that back to the raw amounts, you need to use multiplication. So let's go ahead and do that here. So for A, what we're going to do is we know that 63.8 reported that they drink coffee regularly. We will convert that into a decimal. Whenever you need to do arithmetic with percentages, you want to put them as decimals. If we do that, we'll move that over and get 0.638, and then we will multiply that by the amount of people, which is 260. So multiplication of a percentage will give you the actual amount. That's something we can do on the calculator. 0.638 times 260. You should get that that comes out as approximately 165.88. Now, obviously, that doesn't make sense for how many adults. Adults is something that's discrete. It has to be a whole number. So we will round this to the nearest whole number. So this means 166 adults said they drink coffee regularly. If you want, on your own, what you can do is you can take 166, divide by 260, and you will get back to that 63.8%. All right, let's try the next one. For B, we want how many adults in our survey said they drink tea regularly. Same idea, we'll convert this to a decimal. So we'll move this 2 places over. So it'll be 0.231 times the 260. Let's see what we get there. Calculator, 0.231 times 260. Looks like you should get 60.06. Round that. Nearest whole number would be 60. So 60 adults said they drink tea regularly. And then finally for part C, same approach, 50.4, well, take that as a decimal, 0.504 times the 260 people in our survey, 0.504 times 260, that should give us 131.04. Round that to the nearest whole number, 131 adults said they drink soda regularly. Okay, so this practice problem here is basically just making sure that you're comfortable taking a percentage, using that to get back to the actual amount of people or individuals in a survey that responded in a particular manner. In this case, we just want to remember if you have a percentage and you want to get back to the raw amount, you need to use multiplication. On a more interesting note, let's think about why these percentages do not add up to 100%. If you take 63.8 and 23.1 and 50.4, you get a much larger than 100%. Why is that? Well, of course, if you think about this question, you could theoretically answer yes to all of these questions, right? You might drink coffee regularly, tea regularly, and soda regularly. Or maybe you drink 2 of them regularly, or 1 of them, or none of them, right? It's not where each person gives one response. Whenever you're in a situation where people can give multiple responses or no responses at all or something like that, there's no reason that the percentages should all add up to 100%. So the sort of way to explain that is that since each person can possibly give multiple responses, no guarantee the percents should add up to 100%. So if you ask them what is their favorite beverage between coffee, tea, and soda, then the percentages would need to add up to 100%. But if you ask them which of them you drink regularly, well, somebody might say all 3, and that's going to make the percentages no longer add up to 100%. All right, let's go ahead and take a look at another one. So for question 4 here, we've got a survey of 450 younger adults, 625 older adults, about concerns about climate change. And once again, we get that the percentage that reported being concerned for young adults is 71.1, and for older adults, it's 62.7. And what you'll notice here is that this should be very similar to what we just did in question 3. We're being given percentages, and our questions are being asked how many actual people felt this way. So let's go ahead and we'll bring this onto our sort of work page here. All right. We'll copy that. Let's go ahead and put this right here, question 4. All right, zoom in so we can see that a little bit better. All right, so for this one again, we are talking to 450 younger adults, 625 older adults. We found that 71.1% of the younger adults said that they were concerned about climate change, whereas for older adults, it was only 62.7%. So for A, we want to know how many younger adults in your survey were concerned about climate change. So we know that that's going to be a multiplication. We need to convert this into a decimal. As a decimal, it'll be 0.711. And what are we going to multiply by? Well, it says how many younger adults. We know that there were 450 younger adults. So let's take that and multiply that by 450. And if we do that on our calculator, so 0.711 times 450, you should get about 319.95. So that means if we round to the nearest whole number, 320 young adults were concerned about climate change. Okay, perfect. B should be similar. How many older adults in your survey were concerned about climate change? Well, we convert this into a decimal, so that's going to be 0.627. We multiply this not by 450 this time because we had 625 total older adults, so we multiply by 625. Let's go ahead and see what our calculator tells us there. 0.627 times 625. That should come out as 391.88 or something. If you round that, you should get 392 older adults were concerned about climate change. All right, perfect. So we now know that in our actual survey, 320 out of the 450 younger adults were concerned about climate change, whereas 392 of the older adults out of the 625 were concerned about climate change. Notice that we had more older adults concerned about climate change, but it's a lower percentage because we talked to more older adults overall. That's why percentages are such a powerful way of understanding things. If you looked at 320 versus 392, you might think that older adults were more concerned. But of course, you have to look at it out of how many people you talk to. That 71.1% really tells us that the younger adults were more concerned. All right. let's look at C. C says how many adults, regardless of age, in your survey were concerned about climate change. This should be very easy. We know there were 320 here, 392 here. We just add those together. 320 plus 392. Why are we free to just add them? Well, it says regardless of age, so we can just combine them together. If we do that, we should see that that's 712. So 712 adults in our survey were concerned about climate change. Finally, as just a little bit of fanciness, we've been sort of going from percentage to raw amount here. And now we're going to go back to percentage. What percentage of adults, regardless of age, in our survey were concerned about climate change? Well, we know it was 712 out of how many? Well, we'll have to combine the 450 and the 625. So it'll be 712 divided by 450 plus 625. Why are we combining these? Because it says percentage of adults, not of younger adults, not of older adults, but out of all the adults we talk to. So this would be 712 divided by 450 plus 625. That's 1,075. Then we actually do that division. We should get that comes out as approximately 0.662, and then that would give us 66.2%. So 66.2% of people that we talked to, forgetting about what age they were, turned out to be concerned about climate change. What you guys actually just have calculated here is something that's called a weighted percentage. Notice that this 66.2 lands directly in between the percentage of younger adults and the percentage of older adults. Another interesting fact is that this 66.2 is a little bit closer to 62.7 than it is to 71.1. It's not right in the middle. It actually is a little bit closer to 62.7. Why is it closer to 62.7? Well, because we had more older adults in our survey. So that means that if you do a weighted percentage, which is what this really is, that percentage that you get is always going to land in between these two, but it's going to be closer to the group that had more people in it overall. So just some things to think about as we're calculating these percentages. All right, let's wrap this up by taking a look at the last question on this practice. So for the last question here, we have a survey about El Camino students and their educational goals. So in other words, what are they trying to achieve in school? So let's go ahead, grab this stuff, and then try this on a separate page here. Okay, we'll copy that. And we'll go ahead. Okay. We'll go ahead and give ourselves one more sort of fresh page to work on. This will be question 5 that we're going to be doing. And let's go ahead and paste in our stuff. Okay, so we have this survey of 440 El Camino students about their educational goal. So we get some results. We have that 126 said associate's degree, 175 said bachelor, 62 said master's. Somehow we lost the information about the PhD, and we got that 67 people said something other than what was listed here. Maybe they're just taking classes for their own benefit or a technical degree, or who knows, right? So the first thing we want to do is try to figure out how to fill in that missing number from the chart. It's not just a typo, it actually is intentional. How do we fill in that missing number? Well, the key is that we know that there's 440 people overall, and everybody had to go into one of these categories. So that means that whatever is left over from this 440 should go here. So to do this, what we can do is we can take our 440 and subtract the sum of all these other ones, because we can say all these other people pick something else, so whatever's remaining are the people who picked trying to get a PhD. So if we add 126, 175, 62, and 67, you should get that is 440 minus 430, and if we subtract that, that is going to be 10. So we know that that missing value there should actually be 10. Now, if we add these together, what you'll find out is that they add up to 440, which is what we expected since that's how many people we surveyed. All right, we've got some percentages to calculate here. So I guess this right here was A. Let's go ahead and do the others here. What percentage of students surveyed said they wanted to get an associate's degree? Pretty straightforward here. We'll take that 126, divide by that 440. So 126 people said they wanted an associate's degree. That was out of 440. 126 divided by 440 gives us something like 0.286, which is 28.6%. For C, we would say what percentage of students wanted to get a master's or a PhD? Well, when you see that or there, or is telling us that they could pick one category or the other, we want to combine those. So in general, especially in statistics, seeing that word or, that logical operator or, often means that we want to use addition as our operation. So we're saying they could want a master's or they could want a PhD, so we will combine these two. So that means we'll take the 62 people who wanted masters plus the 10 people who said that they wanted a PhD, add them together, and then divide by 440. Notice that that's going to be 72 out of 440, and if we do that division, 72 divided by 440, that should give us approximately 0.164, which tells us that 16.4%, or about 16.4% of people we talked to said that they either wanted a master's or a PhD. So if you see that or, you just know that you need to combine them. All right, for D, we want the percentage of students who did not want to get a bachelor's degree. Couple ways that we could do this. One way is we could add up all the people who did not want a bachelor's degree. So approach 1, and then we'll talk about a slightly faster way. We could say take all the people who said associates, take all the people who said masters, take all the people who said PhD, take everybody who said other, add them all together, and divide by 440. Well, if we do that and we add all those up, 126 plus 62 plus 10 plus 67, that's 265 divided by 440. Then do that division, 265 divided by 440 should get approximately 0.602, which is 60.2%. So about 60.2% of our sample said that they were not going to get a bachelor's degree. That was not their end goal. What's a slightly faster approach from that? Well, instead of adding all those up, right, instead of having to add up all four of those numbers, we can just simply say we know that there's 440 people total, and we can just remove all the people who wanted a bachelor's. So we can do this as 440 minus 175 over 440. Well, 440 minus 175, you won't be surprised to see that that just gives you a faster way to get 265. And then, of course, it's exactly the same from there. You still get 60.2%. There's even a third approach if you wanted to. Again, any one of these is fine, but I just want to write them out. Approach 3 is to get the percentage who want bachelors. So how would we do that? Well, we would take the 175 and divide by the 440. So we'd say 175 divided by 440. We can go immediately to our calculator. 175 divided by 440. We should get 0.398, which is equal to 39.8%. So that's the percentage who want bachelors. The remaining percentage is the ones who do not. So percentage who do not want bachelors would need to be 100% minus 39.8%, which of course gives us 60.2%. Now, do you need to do it all three ways? Absolutely not. The point is that there's several different ways to arrive at the same conclusion, just deciding how you decide to manipulate it. I would sort of view this as the brute force approach, and these two as two slightly more clever ways, just depending on whether or not you'd like to think about the total as the total amount of people 440, or as the total percentage 100%. Okay, this wraps up the sort of practice 0, the preliminary practice problems, to make sure you're comfortable with the prerequisite material for this class. In the next practice, we'll be doing some practice examples relating to basic definitions, sampling techniques, and working explicitly with categorical variables.